this is a conversation I've been waiting to have for a year because this is the topic that Lloyd and I started this whole thing about back in April, I think it was last year. And I'll just tell this short story to get it going, because it was a year ago in March that Lloyd and I wrote Adam and Ivan and said, how could you say that Maine's forest offset 70% of Maine's fossil fuel emissions? And to us, the word, Adam's okay with me now, I think. Ivan was always okay. But to us, the word offset had a fairly precise definition in the offset marketplace. And at least in the marketplace, an offset had to be carbon over and above what would have been sequestered anyway. That's how the market, and we all know this because we've talked about it at length. But what we learned back from Ivan and Adam is that, and then eventually Stacy, is they didn't mean offsets like we were thinking about offsets. They had another idea of what offset meant. And it was really an offset with a little o, maybe you could say. It was the carbon accounting system. And they didn't mean it like we were interpreting it. So that's all fine. And we're all friends. But it is a really interesting topic because Maine has a carbon neutral goal. And how the heck do you do that at the state level? And so we thought we'd get Stacy back. Stacy's joined us on some of these from DEP, who is I think she's proud to be called a data nerd, is my best guess. She's not something she's ashamed of. But she's the emissions inventory section manager, if I've still got that right, at the Air Bureau at Maine DEP. So she's going to explain to us how she does accounting at the state level. It's like a 101 class for us forest people. And then Adam's going to come in and explain to us how he and others at UMaine are working on the forest piece of Stacy's great big equation, or if that's the right word. And so we can understand, that 70%, 60, 70, whatever Adam says it is today, it's a big number, and it's going to matter to the state's goal, I think. So that's all we're up to today. Stacy's going to lead off. Adam will follow with more detail about the forest, and we got plenty of time. So if it gets away from us, I'll maybe rein it in a little bit. But otherwise, if you've got a question for Stacy, it's a small group. We know each other. Just jump right in and ask away. So, any questions?
Is it worth your telling us the two definitions of offset, so that we're confusing you to begin with, so that we understand?
Well, my definition was from the carbon marketplace, which you know about, Si, which is an offset is an offset to a fossil fuel emission by some entity, whether it be a company or a state or a nation. I don't know about globe, but anyway, it's an offset to an emission. So whatever you put into the atmosphere, you get back through an offset. Somebody that sells you that carbon has to do something differently than they would have done otherwise to capture that additional carbon equivalent to what you put into the atmosphere. That's how most of us who've thought about the carbon marketplace think about offsets. But I think I'd say, Si, let's see how Adam wants to handle that when we get to Adam, because I think they're using it differently in the carbon accounting. So hang on to it, and if we don't answer it, we'll come back to it.
Okay, thank you.
Yep. Stacy, are you good to go?
I am.
All right, Stacy.
Yep. So for those, hi, morning or afternoon rather.
Afternoon.
For those of you who don't know me, I am the emissions inventory section manager at Maine DEP. And so what that means is I'm responsible for estimating all of the emissions into the air. So from our point sources, we have facilities that report through an inventory reporting system. We work on the National Emissions Inventory every 3 years, which is emissions of everything. That is our point sources, that's cars and trucks on the road, boats, trains, everything down to like dog and cat pee in the backyard. It's everything. And greenhouse gases. And greenhouse gases, until last year, was like 2 weeks of my job. That was it. And it has exploded a little bit, as you can imagine. So I say that because historic greenhouse gas reports that you may or may not have seen were very similar. Every 2 years, there was not a whole lot of narrative because we were more or less told by the legislature that as long as we're meeting our goals, nobody's even going to look at it. So we didn't put a whole lot of time into it. We put a lot of time into the data, making sure that the data was right, but the narrative was not great. And so there's a lot of confusion in there, and I'll touch on a little bit of that and promise you that the one we are going to be delivering to the legislature at the end of December this year will have much more narrative and be much clearer to the layperson because there's been a lot of confusion. Okay, so second thing I want to say is I can certainly not take credit for the big picture, as John just mentioned. That big picture is not mine. What we have done in the past anyway, is estimate gross greenhouse gas emissions. The carbon neutrality piece, the sequestration piece, the carbon budget piece, that's the real big picture, which gross emissions is just one piece of, that is something that the scientists at UMaine have put together. And we plan to use that right now. So I can't take responsibility for the whole thing. Okay, so I mentioned this to John when I first got on, but I will mention it to everybody now. Because a lot of the new data that I'm going to be including, so the stuff that you're interested, frankly, anything related to forests and biomass, we have never included in the past. This is new. And so it's all draft, it's not finalized. So I cannot give a formal presentation on that. So what I'm going to do is run through the presentation I gave, or one very similar, that I gave at the Climate Council meeting in January of 2020. So that was the last update we had. And then what I'm going to do is pull up some Excel spreadsheets and show you how we are planning to estimate the other pieces. So not a formal presentation, I'm just going to share with you my draft data in Excel form on my screen. Yeah, Lloyd? You're muted.
Lloyd, you're on mute? Unmute? Let's see if I can unmute him. Yep.
I'd be curious if you could tell us a little bit. You have a whole diversity of different types of sources, data coming in from all these emitters. How do you know how much CO2 gets emitted from power plant X, from all the cars in the state? From what are the measurements based on that you use to develop those estimates? If you could just briefly characterize your sources and how that's done, because when we look at forests, we have certain ways we know about measuring forests, but we don't really know much about measuring this other field of emissions.
Yep. So we do it the same way that we estimate emissions of everything. So any entity that is regulated in the state, in our state for air pollution, it's primarily point sources, right? We have 135 point sources that they emit enough that they have to report their emissions to us every year. And they report their greenhouse gas emissions. They also report criteria air pollutants such as VOCs, NOx, SOx, PM, those sorts of things. And then every 3 years, they have to submit hazardous air pollutants. Now, many of these, not many, well, I'd say many of these facilities have at one point done what's called a stack test. And so someone actually goes in with an instrument and measures the emissions of X, Y, or Z pollutant. And then they use that stack test for a number of years to estimate their emissions throughout the rest of the year based on whatever their operating parameters are. The amount of throughput of whatever fuel, the unit that fuel is used in, how old that unit is. There are specific what we call emission factors for everything. So if you have a generator, it's XYZ model and you burn whatever, we have an emission factor for that, for a number of different pollutants, including greenhouse gases for some of them. Greenhouse gas emissions, though, there don't tend to be controls. So with things like NOx or SOx or particulate matter, a lot of these facilities have control technology. So they have another piece of equipment on top of that equipment that reduces the emissions. We only see that a little bit for CO2. There's I think it's called a calcium carbonate precipitator. That's the only piece of control technology I've seen for greenhouse gases. So for greenhouse gases, typically we estimate those emissions based on their throughput. So whatever it is they're combusting. If they're combusting natural gas or some petroleum product or biomass, we use EPA's Part 98. So it's in part of the CFR. I think it's 40. It's Part 98, and Part 98 is this long document, and it lists lots of different ways that you can estimate your greenhouse gas emissions, whatever industry you are in. And so that's what we use for pretty much everything, is Part 98, when we have a source that has a throughput. Does that make sense?
Good. Okay, good, thanks.
And we do the same sort of thing for everything else, really, for all types of pollutants. Did someone else have a question?
Don't think
No.
so.
Okay, all right. So let me share my screen real quick here. Let me start this slideshow, and we'll just run through this first. From beginning. Pull this over here. And let me share my screen. Okay, do you see a presentation?
We do.
Yes.
Do you see just one slide, or do you see like the
Just
messy
one.
PowerPoint? Okay,
Just one.
excellent. Perfect. So first off, has anybody not seen this presentation?
I have not seen this presentation.
No,
Okay.
I don't think I've seen it. No.
Okay.
I've
okay.
not seen this presentation.
Okay, excellent. Thank you. I was just going to fly through it super fast. I'm still going to go kind of fast because this, you might not be
Yeah.
interested in the totals, but I won't spin through it as quickly as I was going to. So this is the presentation I gave at the last, couple of climate council meetings ago. This is the data from the most recent greenhouse gas report. It comes out every 2 years. We have another one due to the legislature December 31st of this year. So to give it away at the start, this is kind of where we stand, right? So in the greenhouse gas report, what we do is we estimate emissions going all the way back to 1990 to see where we are in relation to our goal. So back in 1990, you can see here for gross emissions, we were at 21.2. So this blue line here at the top are gross emissions. That's everything, okay? That's including methane and all the greenhouse gases, SF6, the works. This green line right here, just below it, is just CO2 from burning fossil fuel. As you can see, that is the lion's share of our emissions, but it's not everything. So we look at it both ways, and we can break this down and slice and dice it any way you want, but this is a good summary. So these are in million metric tons of CO2, and then our years are along the bottom. So you can see here, our goal, this dotted line right here, we needed to be at 10% of 1990 emissions. That's our goal. So we needed to be at 19.1. And in 2017, we were at 17.5. So we were meeting our goal, which is great. You can see right in the middle here, 2002 was our peak at 26.5. And then we've seen a decline ever since then, primarily due to a decrease in the use of fossil fuels. By 2008, right around here, our emissions were below 1990 levels, which was great. In 2012, that was our current low. And then we rebounded a little bit here between 2013 and 2015, and now we're coming back down again, which is great. Coincidentally, we're at 17.5 million metric tons of CO2 equivalents, which is 17.5% lower than 1990 levels. I triple checked that number because that was too perfect, but it is true. So that's great. That's something to celebrate, but we have a long way to go. So you can see all of our goals coming up. Our 2020 goal is to be 10% below 1990 levels. So we've already met that, even though we're not technically at 2020 yet, because this data lags by 2 to 3 years. Keep that in mind. So the report that we submitted to the legislature on January 1st of 2020 had data only through 2017. So this next report will have data through 2019. So we still won't actually know if we've met our 2020 goal. our 2030 goal is to be 45% below 1990 levels. Our 2050 goal is to be 80% below 1990 levels. And then in 2045, we also have that carbon neutrality goal. So if we follow our current trend, we are all set toward reaching all of those goals. The problem is we've kind of already taken advantage of the easy stuff. So it's going to be a challenge to maintain our momentum. But we can do it, we're focused on it, and we have a lot of good ideas. So let's get into how we calculate this data. Maine DEP and all of the other states in the country use EPA's state inventory tool. So this is a series of Excel modules that are all linked together. They have about a gazillion tabs each. I'll show you one a little later. And then there's a synthesis tool that combines all of that data together. So it comes with default data. Each module comes with state-specific default data. Typically, that data comes from national databases, but often those national databases are populated using state data. So in many cases, we are feeding this data up to EPA and up to different federal entities, and then they are feeding it back down to us through the SIT. The states use the SIT so that we are consistent and we're comparing apples to apples. So we can look at Massachusetts inventory and know how they did their calculations. We also avoid double counting, which is really important. For example, if we use electricity in Maine and that electricity was generated out of state, we don't count those emissions. You count the emissions where that electricity was generated, because physically that is where the emissions happened. It might be our fault those emissions happened because we wanted to use that energy, but they didn't physically happen in Maine. We'll talk a little bit more about different ways to look at that too. So the lion's share of the data in the SIT comes from the Energy Information Administration, the SEDS database, the State Energy Data Systems database. And that looks at various types of fuels, mostly fossil fuels, that are reported up to government agencies. So they have a pretty good handle on like petroleum products. That data is really good. So the CO2 from burning fossil fuel data, we have a lot of confidence in. In addition to all of the state defaults in the SIT, we can change anything. And we do. There are a series of modules and we go in and tweak some things. We add vehicle miles traveled, for example. We don't use the defaults because we have a better estimate of that in Maine. We've taken the time to improve that estimate. So we enter that data in instead. We enter solid waste landfilled. We change the methane flared at landfills. So there are a number of different data pieces where we know we have better data and we go in and tweak that. I just heard a...
Yep, I got it.
You tell me if somebody has a question, because I can't see everybody while this presentation is up. I just see like 4 of you.
Okay.
Okay, so we go in and make changes where we can to improve those estimates. And where we don't have better data, we let those state defaults hold. But as I said, a lot of time those state defaults are actually data that we have fed up and is being fed back down to us. The units that you'll see the greenhouse gas, the data reported in, is million metric tons of CO2. So that is just carbon dioxide. Typically that data is from burning fossil fuels only. And that's going to be reported by sector: residential, commercial, industrial, transportation, and electric utility. And this is where it gets confusing. And I did not do a good job in the last report of describing the difference between sectors and sources. Because when you talk about CO2 equivalents, in this case, million metric tons of CO2 equivalents, you're talking about all the greenhouse gases converted into CO2 equivalents to be able to compare apples to apples. So we use the global warming potential that's reported in the IPCC report, the latest report, and convert kind of the contribution, the warming contribution of each of these greenhouse gases into what it would be if it was just CO2. So they're reported differently. CO2 equivalents are typically reported by source. We're talking energy, agriculture, waste, and industrial processes. And then the CO2 from burning fossil fuel is broken down by sector. You can't add these two things together. Okay, they are each kind of 100% of the pie. So I will do a better job of breaking that down in the next report, but there's a lot of confusion there. The main takeaway here is look at these two things separately. You can't add them together. Okay. Currently, renewable energy sources are not considered. And that is standard across the board for the SIT. We assume that they are neutral. And I know that there's a lot of debate about, well, how far out into the future are they neutral? So in the next report, we are going to be counting these. We have to start talking about net. So we're going to be bringing them back in, but they are not included in the SIT. You cannot calculate emissions from renewable sources in the SIT. So we are having to figure out what pieces are missing and add those back in. And we'll be reporting them two ways, both with and without renewable resources or emissions from renewable resources. Okay, so let's get down to the results here. For those of you who haven't seen this, I'll walk through it quickly. So this is gross emissions by source category. So as you can see here, the demand for and consumption of energy really drives the clear majority of Maine's greenhouse gas emissions, right? So this big 90% piece of this pie, that's energy. So that's our fossil fuels primarily. Agricultural activity, industrial processes, and waste disposal combined only contribute to 10%. So they're a smaller piece of the pie, but 10% is still no joke. So we need to consider that too. So let's break this down and look at it over the time series. You can see in 2017, the total energy consumption in Maine was 14% less than it was in 1990. So again, this is just that energy piece of the pie that we're talking about, that 90%. Petroleum specifically in 2017 accounted for 49% of all of the energy consumed, but it also accounted for 84% of the CO2 emissions. So that's the whopper, right? That's where we can point our finger. The reduction in residual fuel oil consumption since 1990 was 95%. And so that is a large driver of the overall decline in greenhouse gas emissions. Yeah, so let's jump. So you can see all of these different fuel types in the colors. Wood is 25%. So that is something, the emissions from wood is something that we have always ignored. We have assumed that it was neutral and we did not include it in our gross emissions. We are going to be including this going forward. And so this is going to bump our gross emissions up quite a bit. And I'll show you that after this presentation, what those look like, what the draft data looks like. So if we break down this petroleum piece right here, you can see all of the usual suspects in our petroleum type, different types of petroleum, with distillate fuel being this blue here on the bottom, motor gasoline being the next biggest here in the red. So there's been a 26% decrease in CO2 emissions since 1990 and a 23% decrease in consumption. So those match up nicely. Okay, so let's look at the sectors that I was talking about. So this is just petroleum consumption. And you can see transportation here in purple takes the lead. This is the only sector that has actually increased in consumption since 1990. And then if we look at the emissions, this is CO2 emissions from fossil fuel combustion by sector. So here we go, transportation, no surprise, 54% of the CO2 emissions. This is in 2017. And if we break that out into a time series, you can see transportation up here taking the lead, obviously. So there's actually a 54% of CO2 emissions in 2016 are due to transportation, 2017 are due to transportation, which is up 2.5% since 1990. All of these other sectors, you can see these little numbers here on the side, have seen a decrease in emissions in terms of CO2 from combustion of fossil fuels, but not transportation. Transportation is actually up.
Stacy, is that because there are more cars on the road, even though mileage efficiency ratings have increased? We've just outpaced that with more cars on the road.
Exactly,
Okay.
exactly. So each individual car is definitely more efficient and cleaner burning. But yeah, we have a lot more people driving and a lot more cars. So we know where the big areas are, right? The big areas are residential and transportation. Those are the big burners of fossil fuels and the big contributors to CO2. The industrial sector has been very heavily regulated, so they've brought down all of their emissions. Greenhouse gases aren't necessarily a target, but in reducing their emissions of all of the other pollutants that are more heavily regulated, like PM and SOx and NOx, everything starts to come down because burning fossil fuels creates a lot of emissions. It's not just greenhouse gases. And so many of these industries have changed. They have improved their efficiencies. They have switched from different, one fuel to another, like number 6 fuel oil to natural gas. that you're going to see a huge change in emissions, not just of greenhouse gases, but of criteria air pollutants as well. So that was really their motivation for doing it. And now they have new motivation, which is the greenhouse gas reduction. So a quick summary, gross emissions in 2017 were 17.5% below 1990 levels. So that's great because we're supposed to be 10% below 1990 levels by 2020. 90% of the emissions are the result of energy consumption. So that's mostly the combustion of petroleum products. 54% of main CO2 emissions in 2017 were from the transportation sector, no surprise. And CO2 emissions from fossil fuel combustion in the electric power sector have decreased 83% since they peaked in 2002. And so that's a huge win, right? So we've converted to a lot of renewable sources for our electricity, which is wonderful. Transportation and residential sectors both have the highest consumption of petroleum and the highest emissions of CO2 from burning fossil fuels. So those are our big targets. But we really do need to look at everything, obviously. So that's a quick summary of where we were with the last greenhouse gas report.
Can I stick in a question real quick?
Yes, of course.
Very striking, the decline in residential emissions, if you could move back a chart or two, from the peak right there in about 04. What do you have a sense of what underlies that?
I do not. This is fossil fuels, so this is going to be really your home heating oil primarily. Wood is not included in this at all. So this is home heating oil and natural gas. It could definitely be the switch to natural gas, although that seems a little early to me.
And it's not that widespread, is it?
Not yet, not in Maine, because this is Maine specific. This isn't across the country. So in Maine,
it would be interesting if we had a better sense of what underlies this, since it's such a large point, and since it started to grow again, moving against the trend of the others, actually.
Yeah, natural gas is becoming more and more mainstream. I mean, my neighbors got it, which was big. We don't yet. I can tell you it's really embarrassing going to national emissions inventory conferences, because in Maine, we like 50% of our residential heat comes from number 2 fuel oil. And across the country, it's like 8%. So it's, yeah, we don't look good. Like people think like 50%? Yeah. So we're moving away from it. We don't even talk about wood at those conferences.
Stacy, this is Daigneault. How are you?
Hi, good, thanks.
Maybe you're going to get to this, but I've always referenced a spreadsheet that you folks put out, which has a facilities site, a list of all facilities that emit greenhouse gases. And I think 2018 is the last one I could find.
Yep.
So the gross greenhouse gas emissions from that crowd is 10 million tons a year. At least this the way the column adds up, of which 4 is from biomass sources and 5 is from non-biomass sources. So am I assuming that the 5 is what's in this chart?
Correct.
And so that when you throw biomass sources in, it's going to be a big jump.
It's
right?
a really big,
aren't we at 13 or so
big jump.
total?
Yeah, it's a really big jump.
And
it's about 10.
And the fascinating thing to me, maybe you'll get to this, is 80% come from the paper mills.
Yep.
So that's the 800-pound gorilla. Okay.
Yep.
Okay, I'm glad I'm on the same page with you. Thank you.
And that's the only industry I've seen one of those calcium carbonate precipitators on, where they're looking at controlling CO2. I haven't seen that elsewhere. So yeah, let's start talking about that a little bit more. So let me end this.
Just if I could make one reference point, when I was giving a testimony at the legislature on, I think, Tucker's environmental bill, the lobbyists from the paper industry were there in force, and they said, what we want to avoid at all costs is having our biomass burning not be carbon neutral.
We're not avoiding that.
No, I know you're just putting the numbers out, but there's a political process that's
our commissioner is very much supportive of us reporting all of this data. And I'd like to talk about this now, actually, how we're going to report this in the next report. And then we'll talk about the data. I have a major echo. I can hear myself.
I got it. I got it too. It's not major, but I'm hearing it, Stacy. Maybe
I hear myself twice.
if everybody if you could, everybody put yourself on mute. I think that'll help with the feedback. And if you want to
Just
speak,
unless you have a
then
question.
just,
Yeah.
yeah, that, I think that will help us.
Yeah, beautiful.
I'll do the
Yeah, I
same.
don't hear it anymore. Perfect.
Yep.
Perfect. So here is our plan for the next report, because this is all new, right? The last report was very similar to every single report for the last, I don't know, 10 years or so. In this next report, we're going to do a number of things differently. A, we're going to have more narrative, and B, we're going to be educating people more about what this data is, how it's reported, what does it mean, so that the layman can pick up this report and know what we're talking about and not get confused between things like sources and sectors. So we'll lay all of that out. We're going to be as transparent as we possibly can. We are going to report the gross emissions, not including biogenic emissions, so not including emissions from renewable resources like ethanol or wood, just as we always have, as one data set. Then we're going to have another data set where we do include those renewable emissions. So we're going to include the emissions from flaring methane in landfills, which normally you just assume that that's now gone, but really it just turns to CO2, right? So we're going to be counting that. We're going to be counting CO2 from landfills. We're going to be counting greenhouse gases from burning ethanol, and we are going to be counting greenhouse gases from burning wood. So there is a big jump, but we're going to report it both ways so that people can see the difference in the two and they understand where that difference comes from, because we want this to be able to inform policymakers, right? And so that they can develop strategies based on this data. And I think that dividing out the data in those different pools is going to be very helpful, because some strategies you really don't care about biomass because maybe you assume it's carbon neutral 100 years out, and so that doesn't matter to you. For other people, they're looking at shorter term timeframes, and that biomass really is important. So we're going to report it both ways. The other thing we're going to report separately is emissions from electricity consumed in Maine. So that is all electricity consumed in Maine, regardless of where it is generated. Right now, we only count greenhouse gas emissions for electricity generated in Maine. And we do get electricity from outside of Maine. We export electricity, though, as well. So those two for Maine, for most recent years, they've kind of netted out our imports and exports. It's, in my opinion, it's a paper game, right? So if we import 10, whatever the unit is, in electricity, and we export 10, it nets out to 0. But on paper, it doesn't work like that because you're sending electrons out of the state from renewable resources and bringing in electrons from non-renewable resources. It's a bit of a mess, but regardless, for greenhouse gas emissions, we are going to report it both ways. We are going to report it the standard way, how it's done in the SIT, with only electricity that is generated in Maine, because that's where those emissions actually happen. And then we're going to report it separately, the greenhouse gas emissions from electricity consumed in Maine.
Stacy, I don't want to sidetrack you, but quickly, are other states using the same methods that you are? Because if it would depend on who's double counting or not. So,
and that's why we're going to report it separately. So that if someone from, say, New Hampshire or Massachusetts wanted to grab our data, I can tell them, we'll use this data set and you will not have to worry about double counting. Okay. But for those people that are really keen on better understanding how much electricity is consumed in Maine and what those greenhouse gas emissions are, to sort of tackle that piece, it's important that they get the full picture. So we're going to be reporting it a couple of different ways. And other states do this as well. I all of a sudden have an echo.
Yep, I know.
Okay, so other states, it's gone now. Other states do this as well, where they have kind of the core data set that is like every other state, and then they have little satellite data sets that might be addressing a specific focus in their state. Like some states are doing kind of life cycle analysis of their greenhouse gas emissions. That gets really messy, but it's super informative. So that's where it's really a consumption-based inventory. So that tub of yogurt that I just ate, where does that container come from? It doesn't come from Maine, it comes from elsewhere, but those greenhouse gas emissions should be accounted for here because I am consuming that product and throwing it away. So there are different schools of thought on that, but we're actually looking to start doing that as a small pilot project just in a couple of cities, because that's where you can start really teasing out where our greenhouse gas emissions are coming from. And often the inventories look very different. Anyway, we're going to be doing that later. So we're going to be reporting.
Stacy, I was going to ask a quick question.
Yep.
Has the sort of impact of how you take into account biogenic emissions rippled through to how that affects meeting goals yet?
Yep, it does. It does, because our goals are based on 1990 levels. And so when we add those renewable fuel sources in, that changes the 1990 number too. So it
Okay,
changes.
so you're backcasting the 1990 biogenic as well?
Yep. Yep.
Okay.
Yep. Yep. Okay. So why don't we go there? I think I've talked about how we're going to change this next report, the different pieces we're going to add. And oh, the other piece I didn't mention was so with and without renewables, but also with and without carbon credits. So we're going to try to tease that out. We may not be able to do that for this next report, but at least going forward, that's on our radar, because a lot of people are thinking about how do carbon credits work into this, and should we actually count that carbon or not? You know, on paper, we don't get to count it, but physically in the world, it is happening here. So our plan is to be able to report that both ways. So depending on the strategies, depending on how you want to look at the data, you'll have both of those data sets. Okay, so let me jump into the renewables data first. And let me share this with you. Now, let me preface again that this is very draft. And this one. This sharing? Yeah, okay. Okay, so do you see a figure in the middle with like blue and green and orange and yellow line?
Yep.
Okay, great. Okay, so for wood specifically, for emissions from burning biomass, pellets, firewood, the works. We sliced and diced this every which way we could to try to find the best way to calculate this. We looked at the wood processor reports. We looked at the firewood reported there. We looked at the harvested data reported there. We looked at the SEDS data through EIA, which is not great, so we've been told. So we did not think that that was good data, and we were not going to use it. In the end, it's not horribly wrong, at least horribly different from how we've estimated our wood data. So we're using some of it. We don't have internal sources for everything. So when we look at the different sectors, industrial, electric power, residential, and commercial, there are a couple of sectors that we really don't have great data for, commercial being one. We don't have commercial facilities report to us. We have a couple, but not many report to us. We did a survey of commercial facilities in Maine, anybody who had a license with us in Maine for air emissions. We reached out to them and said, how much biomass do you burn? Whether or not it was on their license. And they gave us their totals. And they did not account for enough. Like, we know we are missing huge amounts of data. So we determined that that was not the best way to go about estimating that piece, but we looked at it. We looked at, as I said, the wood processor reports, and we tried to link in home heating, or not home heating, what's that word? Heating degree days, that's what it is. Heating degree days with the firewood and the pellet sales to try to figure out if we could use that data as a baseline and have it change over time based on heating degree days, and that didn't work. So in the end, we decided to do a survey, another survey of all residents in Maine. So we used Critical Insights, which is a company out of Portland, and we had them do an independent survey so that it was not DEP calling people around the state and saying, how much wood do you burn? Because they might have changed their response if we were asking specifically. So we had it as part of the omnibus survey. So that's a big survey that they do around the state. We have done one of those surveys. We had done one in 98, 99. We participated in that. We have another one from, let me check the dates on this. From 2000, we had another one in 2004, 2005. We had one in 2007, 2008, and one for 2019, 2020 is the one we most recently did. So we have 4 of these surveys over time now. And let me show you this comparison. So that's what we're using for residential. what are the other pieces that I wanted to talk to you about? For electric power and industrial, we have required facilities to report to us for a very long time. But the data is not great before 2010. It simply didn't have the quality control. It didn't have the review process that it's had since 2010. So originally, I can show you some of this data here. So this is like industrial wood and black liquor solids. We were pulling that from our old database, and it just didn't make sense. It was all over the place. And so we cut that out, and we are going to be using the EIA data for that. And then in 2010, we are much more confident in our industrial data that facilities have reported to us directly. And so we're more confident in our data than the EIA data. So we're using that from 2010 onward. So let me just show you this. So this is a comparison between the wood data reported through the Energy Information Administration. So this is the data that feeds the SIT, the state inventory tool that we use. It's really great for fossil fuels. It's not amazing for wood, or so we thought. The big difference, it turns out, though, in digging into this is that when folks did the original, like back of the envelope calculation, they were not including black liquor solids. And that counts. That counts as wood. And so we're adding that in, and that is a big number. For some industrial sources, that's half. So it's a whopper. I can show you some of that data here. I know as this comes out, people are going to be very interested in this. So these two lines right here are industrial. The top is wood, the bottom is black liquor solids. If we scroll over here, you can see these numbers. So in 2019, the last reporting year, it was double than the actual biomass. So these are really big numbers. In this greenhouse gas report, this next one, we are going to report this data broken out so that people can see the difference. Because for some strategies, black liquor solids is not going to play a role, just the biomass will. But for other strategies, you really need to consider those black liquor solids. So those are the paper mills, right, primarily. But that's a whopper in terms of emissions. So this figure right here shows you the BBTU, so this is billions of British thermal units, comparing the DEP data that we're going to use and the EIA SEDS data. Now we are using the EIA SEDS data for some of this data. For industrial, we're using EIA up to 2010. And then we're going to be using our own internal data here, which is the bold line is what we're going to be using. This is the SEDS data up here, which is a little bit higher. For electric power, we're going to be using the SEDS data, again, all the way through 2010. And then we're going to be using our own data. And in this case, our data is higher. So you can see that in some cases, it's just how these data sources are categorized. So whether EIA considers a facility industrial or electric power. So some of this is just flipped. If you look at this skinny line right here, that's the EIA data. And so we flipped a little bit here, I think, with industrial and electric power, as long as we're capturing it all. The orange is residential. This thin line down here is what EIA says. This doesn't make a whole lot of sense to me. This does not pass the straight face test. So that back in 1990, our combustion of wood in residential homes was like not even a quarter of what it is today. It hasn't changed that much. It fluctuates over time, but it hasn't changed quite that much. So we are going to be using this bold orange line, which is based on survey data. It's not perfect, but we use a third party and they assure us, and they've shared all the data with us, and it is statistically significant at a state level. We have it broken down by county, and the numbers aren't big enough in some of the counties, like in Aroostook County, for it to be statistically significant at the county level. But at a state level, it is. So that's the data that we're using for that. And we've simply interpolated between the survey years that we have. And we think that is the best method for this. For commercial, we simply don't have enough data. So we're using the EIA data for all of that. So the bold lines here are the lines that we plan to use for combustion of wood in the next greenhouse gas report. Now this is just wood though. So let me stop sharing. Does anyone have a question on this? Because I'm going to move on to the full renewables so you can see the change it makes in the emissions. So here are the emissions from just wood in this figure. You can see the gray is industrial, which has shrunk over time. Electric power is yellow, and so that's changed over time, but right now is a little bit more than it was in 1990. And blue is residential, and commercial is pretty tiny here. So let me stop sharing this and show you the renewables data all together. Here we go. Okay. So this is really the big takeaway. So this figure right here with the green and the blue, this is the old figure, right? The top line here, this blue line is the gross emissions. So that includes all of the greenhouse gases. The green line is just the CO2 from burning fossil fuels, which again is the lion's share here, but it's not all of it. The dotted line here is our 10% lower than 1990. That's our 2020 goal. So you can see we're meeting that. When we add in renewables, this line goes way up. So this blue line is still almost the same. This is CO2 from burning fossil fuels, which now includes, I see people leaning in. Let me see if I can zoom in a little bit here.
That's
so
good.
you guys can see a bit better. Okay, I see all these heads going in like this. Okay, so this blue line is just like the old plot, right? This is the CO2 from burning fossil fuel. This now includes ethanol. That hasn't changed that much. Ethanol is not a huge piece of the pie here, but we did add ethanol back in. The red lines up here are the gross emissions, including renewables, using EIA's version of wood. So the difference between the red line and the orange line up here is using EIA's version of wood or using Maine's new version of wood that is modified a bit. So you can see they're pretty similar, but they do deviate a little bit historically. Primarily that is the residential piece because EIA, we feel, definitely underestimated that. And I've spoken to people at EIA and they just kind of chuckle and they say, we do the best we can with residential wood, but there's no reporting. So it's a guess. It's really a guess. The firewood and the pellet fuels, the sales, because we have sales data for that, and we have the wood processor reports for that, and those numbers are just too low to make sense. So we feel the survey data is a better estimate. This gray line right here, the gray dotted line, is our new goal, the new 10% below 1990 level goal. So you can see we are below our goal still. If you look at the red line, excuse me, the orange line, and I know these are tight, but the orange line compared to the gray dotted line, that's where we will stand when we add in this next 2 years of data. So this was just a draft of us doing this after the last report. So we still need to add in 2018 and 2019. But as of 2017, the orange will be where we were for 2017, comparing that to this gray dotted line, which is the goal. So we're still below the goal, but we're not as far below the goal as we were without renewables. Does that make sense?
Mm-hmm.
Okay, and again, this is all just the draft data. So these are literally my working files that I'm showing you. But this is a big jump, right? This is a huge jump. And wood is primarily the culprit here.
I'm looking at the main carbon budget, which John sent us, and
Yep.
the emissions from all fossil fuels in that flow chart are a little under 5 million tons of carbon, which is about 18
Yep.
CO2 equivalents.
Yep, we're at
right?
17.5 on this figure. This last point here is 17.5. Yep.
So that is what? That's doubling the emissions when we include wood. That's not what your previous
It's not
figure
quite
showed.
doubling. It's not quite doubling. We're going from about 17.5 to 28. So it's adding like another third.
17. Okay, that's still
Yeah.
that's
It's a big jump,
huge
though.
different picture when
Big
you think
jump.
it then.
Yep.
Because we've been in this chart, those emissions are not on that chart. yet the sequestration from the forest is on the chart. So we're taking credit
It's not on
for
this.
forests.
Well, so this is a
Is
little
that right,
different.
Adam, or
So-
not?
It's not on this chart. That's
Not
And it-
on the chart, right?
and it
So
won't
that means
be.
we're taking credit for forests to sequester fossil fuel emissions, but not their own emissions.
yeah.
It's
Neither,
Okay.
I
These are
think we need to wait for me to talk before we
Yeah.
get
Yeah,
into
that's a good point.
Yeah.
Oh.
Yeah. So in order to avoid double counting, we can't count this in the net piece. And no state does. All of the states do it the same way. So if they want to report emissions from burning wood, that's fine, but it is separate from the sequestration piece. I'm going to let Adam talk about how that's calculated, but I'll just give you a little teaser here. Some of that is done based on a stock change in the forest. And so you can't add the emissions from burning wood with that stock change because you'll be double counting.
Mhm.
So we can't do that. Also, as we heard from Grant Domke last time, we can't count emissions from wood combusted in Maine that are brought in from out of state, right? He was talking about that in our last discussion. That wood brought in from out of state, we don't count because again, that would be double counting because it's based on when it's harvested, not when it's actually burned. So these are two different data sets and we're going to be reporting on them separately. One data set is gross emissions and our gross emissions will be reported two ways. One without renewables and one with wood.
Okay.
So
Fair
you can
enough.
see the differences. Then there's a whole nother data set that is the carbon budget that Adam and other folks at UMaine have been working on. And they're calculated very differently and they have to be so that you avoid double counting. And so we're doing it this way to kind of lay all the data out on the table. But just like sectors and sources, you can't add them up. Like it doesn't work that way. They really do need to be considered separately. I hope that.
Stacey,
clears
can
up
I
a
we-
guess
little bit.
I don't understand the double counting, but I'll just hold off and
Can we
listen to
move
Adam,
on
and maybe I
to
will.
Adam maybe, or we're
Yeah.
not going to get
Yeah.
Adam in here? So,
Yep.
uh,
Yep.
So
I can be
Stacey,
done.
thank you for setting that up.
Yeah,
Mhm.
great.
Well, that's big. That's a really big difference. Thank you for
Yeah,
It's a
huge.
huge difference. It's a
letting us
huge
know.
difference. Yeah.
Adam, you got something to say other than
it is,
you're up.
but the kicker is in our budget, we estimate wood decay. Okay. The wood decay, if you convert this to million metric ton CO2 equivalent, it's 11 million metric ton CO2 equivalent, which is spot on with what Stacey estimates people are burning.
Mhm.
Right. So our decay is basically anything that's removed from the forest that's not turned into some product, right? And firewood and any sort of chips don't count as a product. So
Right.
in a weird way, maybe we've got it at it two completely different ways, but have converged to the same.
Very close. Yeah.
Fine. That's a kicker with what I'll kind of go over, but that's really fascinating and good to know, Stacey. Good to learn.
Adam, are you ready?
Yeah, I'm getting on it.
Okay.
Let's see. Are we? Maybe?
Yep, we got it.
Okay. I'm going to stop my video just because for some reason my internet's been bad since we had that storm last week. So
Mhm.
bear with me.
Mhm.
All right. So we only have a certain amount of time. So my guess is we're not going to get much farther than the forest carbon budget. But again, I have more calculations on harvested wood products depending on how we get there, which obviously ties in well with what Stacey was just talking about. All right. So what I'm going to talk about first is this totally pro bono study that a number of us at UMaine, in addition with help from Jeremy Frank at the Forest Service and then Bev Johnson at Bates College, who worked on the blue carbon part, basically out of interest, tried to say, how can we actually sort of follow along with a similar methodology that's is conducted at the US level for the state of the carbon cycle report that Dr. Dan Hayes was part of. How can we sort of replicate that in Maine with sort of readily available data, all done on the cheap? So was about a year ago that we actually came out with this. We've had a number of questions from several of you on the call. Sounds like Bob just caught wind that this existed, so more questions are bound to come soon if I know how Dr. Seymour thinks. But we'll see. Hopefully this isn't completely new to all of you. So the idea behind sort of the full carbon budget and how it sort of varies somewhat from sort of Stacy or DEP's approach is that we're really trying to capture all components of what the atmosphere actually sees, right? And so there's sort of fluxes that involve sort of pulses of emissions and whatnot going up into the atmosphere, but also that additional, ecosystems themselves can uptake carbon through their processes as well. And we're trying to track sort of where these fluxes occur in all the sort of major components of things that contribute to greenhouse gas emissions. All right, so in our world, we're really thinking about trees take up carbon from the atmosphere through photosynthesis, add it to biomass, right? We know that. As the carbon cycles through the ecosystems return to the atmosphere through decomposition or incorporate into the soil, right? And then also, and the key part here in Maine, or the thing that we're most interested in, is in managed forests, the biomass is also removed, all right, in harvests, and that seed can be made into short or long-term products. Those products can then end up in a landfill, or those removals can be turned into some form of biomass that's either in some way it's combusted or left on the essentially, pile somewhere, side of the road, whatever, eventually decomposes and decays. And so when you see the word decay, when it comes to forests, it's really a much broader term in a carbon budget sense. It's not necessarily about sort of coarse woody debris decaying in the woods. It really has to do with any sort of piece of wood that's accounted for as being removed from the forest. What is it basically what does it turn into over that life cycle? And so forests themselves, right, through photosynthesis take up carbon, right? We harvest and remove some of that, convert it into wood products. And then some of those wood products then are decayed, right? Or some of that forest removal is directly combusted as biomass, which also counts into this decay space. So any sort of combustion is also counted as decay in this world. In addition, forest biomass can also be transported through our inland waters and then deposited as sedimentation. And we attempt to capture that as well. All right, we're also sort of in other pools, we're trying to account for carbon and crop residues, as well as emissions, through livestock. The livestock emissions coming straight from Stacy's calculations, and we were very gracious that she shared the more detailed stuff that we can see in terms of knowing livestock by different types of, emissions by different livestock and things like that. In built environments, carbon stored in trees, gardens, lawns, wooden structures. All right, and we're also trying to track for the sort of potential uptake that can happen on sort of urban landscapes as well, and that is through could be potential. So the reason we're trying to capture this is that you can have basically forest sort of land use change that shift into one and the other, and just because something goes from forest to developed land doesn't mean that all the carbon is potentially just kind of either released or the storage goes away, right? It's just a different way that carbon's stored under a different sort of ecosystem or category. And we're trying to account for that as well. And sometimes that's not adequately accounted for if you're looking just in a sector specific or land use specific, because when the area changes, that carbon sort of disappears, right? But it doesn't truly disappear in a carbon budget sense. In addition, we're attempting to also capture carbon that can be stored in wetlands as well. And as I noted, this idea of inland water. So carbon can be transported from land through Maine's rivers to the ocean, right? And some of that carbon is buried in lake sediments, while much of it is outgasses from the water column, right? We attempt to try to track for that. And again, I noted this idea of blue carbon. That's what's found in salt marshes and eelgrass ecosystems. And they have high rates of carbon storage in their sediment, despite a relatively small area in Maine. So the density of carbon in our sort of inland coastal waters are quite dense. this is the sort of just cut to the chase in terms of absolute and relative estimates of sort of the density over the different land types that we're trying to capture. And so on the far right-hand side is sort of the best way that I like to look at it, is essentially there's sort of two components here, right? So there's the area, right, which is going to affect that. And then there's the density across that area, which is ultimately going to lead to the total carbon stock. So I talked about here sort of like wetlands, salt marshes, all right, they have relatively high carbon densities, because there's relatively low rate, the total carbon stock that is relatively low range to sort of a mid-range density. So if you sort of account for that in terms of the sort of different components that we're trying to estimate this over, you can see that there's sort of different components have different rates of either net emissions or uptake and decay, right? And so the ones we're most interested about is the wood products in the forests. All right. In addition, what we haven't talked about is the fossil fuels that Stacy did a nice job touching upon, right? That's a major source of emissions that prior to this sort of changing and accounting for basically from fossil fuels, ignoring this biomass emissions that we're going to sort of get into both in our talk and then obviously in the next set of reporting, according to Stacy, this is the greatest source of net emissions within Maine. So Stacy already sort of touched upon these aspects. So I'll kind of flip to that. All right, so thing we're interested in about most is basically the forest level, right? So forest stocks and wood products, all right, they're primarily estimated through the U.S. Forest Service as well as the Maine Forest Service, of which Jeremy Frank helped me on the wood product side of things. On the forest side, it was primarily Aaron Weiskell and I. Right, and so a lot of these numbers come from FIA, which are measured on the sort of five-year cycle here in Maine. Other land fluxes and other land covers are estimated locally, but really we're really looking there at land use change effects, where we're looking at land use change from one land use type to the other and counting for the relative difference in that carbon density going from one land use to the other. Sort of that's what we're looking to estimate that. And the other key thing is what I want to point out is that what we're trying to do here is that we're looking at basically an average stock change or an average flux from 2006 to 2016. So that was our source of estimation. When we began this exercise was back in 2019. That was the sort of 2016 was the latest sort of year that we had a consistent set of data across all these basically pools that we're looking to estimate. All right, that's also conveniently the point of the latest national land cover data set. So that's the sort of latest info that we have on a consistent and sort of high resolution level on land use change. All right, so from there, what you can do is basically, this is primarily through FIAs. You can measure sort of major components of the forest, which consists of live biomass, dead organic matter, and soil carbon. And you can look basically in 2016, you measure that out, 2006, you measure that out, and you take the difference between the two and then essentially divide by 10 to get the mean across that 10-year period. All right, and so based on that, you can get sort of a mean of 2.675, basically net increase in live biomass, 132,000 million metric tons of carbon in dead organic matter, and 133,000 tons in soil carbon that have increased over that period, for a total forest carbon amount of 2.9 million metric tons of carbon per year, which is roughly upwards to 10 million metric tons of carbon. So that's net. So that's, you go out and measure the forest, right? That's what you're going to see. You measure that, measure enough plots in 2016, measure enough plots in 2006. That's the stock change that you're going to get just going out and measuring the forest. All right, but we know that's not the only component of where sort of carbon pools lie in terms of wood.
Adam, just a clarification, that's below ground live as well as the above ground. That's what threw me off, I think. Okay,
yeah,
right?
Yeah. So it's everything in the forest ecosystem that FIA measures. So good question, Bob.
Yeah, because the above ground, we were looking at Ken Lawson's worksheet earlier in this session months ago, and that the above ground live is only like 330. right? So there's a significant amount below ground. And I guess the question I'm just wondering about is how dynamic that is, but I'll just defer that until I'll let you go on here and see.
Okay. Yeah, we can talk about that more. I have tried to plot out some of the differences with that above and below. I think also
okay.
we can talk about that. The other thing, and this is where I thought your other question sort of came at, Bob, is the number that I'm showing now, I'm giving you basically this box here, right?
Yeah.
I'm not talking about this net. I'm not talking about this number that starts up here that's at 7 something other million, right? We know also from FIA how much is harvested or is removed every year, right? And that's estimated at 3,780. All right. From that, basically,
I get a way different number, by the way, when I draw that. So we have to look and see what number we're actually using. It's way higher than that.
Okay.
If you look at harvest up just above ground, right? We're not harvesting below ground. You get.
And so I don't know what year you were looking at, right? This is an average over.
Well, it was the most recent year that I could pull out of the validator. So
yeah. So it might be the year that you're pulling from as well.
Anyway,
that might have something to do.
I don't think that's it, but whatever.
We can talk about it offline, and I can help you. Jeremy and I did a lot with this, but there's always places where this can be improved. Okay, so the next state of what we did then, all right, so this is the amount that's removed from FIA in terms of million metric tons of carbon again, all right. And then based on Maine Forest Service sort of numbers, we know how many like sort of green tons or cords or 1,000 board feet are harvested on a year-by-year basis. So we took the mean over 2006 to 2016. All right. And then based on, it looks like probably we won't get that far into my other sort of talk, but there's basically decay factors or conversion factors that you can use based on studies by the Forest Service that say what proportion of a green ton or whatever, unit you want to do, what proportion of that, whether it's hardwood or softwood, pulp or saw log, basically is sort of stored in an actual product over the next 100 plus years. How much of that actually goes into a landfill over the next 100 plus years, and how much is basically just sort of disappears in the sense of either it's combusted as energy or it's not adequately accounted for anywhere. But we know that it's definitely not stored in a product. So the numbers here are the ones that we estimate they're actually stored in a product, basically over sort of on average over a 100-year period. All right, so from that, you can basically, the next phase is basically from that you can deduce, well, 3,780, and then this is storing some like close to sort of 750,000 tons. Then that means that there must be 3,026 tons that are decaying or somehow being combusted or basically not being stored in any products or landfill, right? If you convert that by multiplying 3.67 to CO2 equivalents, that's getting you somewhere between 10 and 11 million metric tons carbon dioxide per year, which is very similar to what Stacy just pointed out with the estimates that they've done. Okay, so that's sort of how we track those different pools. In addition, there's sort of using other methods, you can sort of estimate the proportion of sort of uptake in forest that also gets sort of deposited into inland waters via sedimentation. All right, and that's sort of outside of what I've done, so I can't answer too much on that. Ivan and others might be able to do that in more detail. All right, so from all those different components, right, you take the decay, you add back in the wood harvest, you add back in the inland waters, we can get back to the 7,151 that we take at sort of, that was what the forests were doing before we removed anything and turned it into products or anything sort of started going downstream and ended up as sediment. So maybe, John, when you said you're always trying to figure out what the numbers are, that might be where you're getting a little bit confused. So what I did while Stacy was also talking is I tried to come up with this pool that actually, this calculator, a way that says, how do I come up with all these different numbers that's in that, in the prior diagram by adding up the different types of pools. And I checked my arithmetic and at least the pools are all lining up. So at least we have that aspect, right? But the key is that actually the total uptake that you often think that you start with, that's a calculation actually based on the total inland waters, the removals, less the products, which gets you the decay, as well as the 3 pools that we know on net are in the forest over that period. So you kind of add the 431, 330, 26, 754, 29, 2940, 3026, 431, you're going to get this 7,151, I believe. So
So
that's how,
just to clarify, the total removals is from what? 3780? What is that from?
that's from FIA on average between 2006 to 2016. That's the average amount of carbon that's basically estimated in that removal category.
If you do that now with the validator, you're going to get a way higher number. So I would definitely go back and check that.
Carbon dioxide equivalent green tons. What's the metric?
There's 13 points, the 16.8, 16.1 English tons million.
Yep.
Grew. That lines exactly up with your 7151, the uptake. That's exactly right on. If you FIA also says 13.8 million tons are being cut. And if you do the math on that, you're going to come up with something like 8,000, not 3780. So on the same units, 1 inch and above ground. Nothing, this is not below ground, right? Because we're killing that, but we're not utilizing it for anything. We're harvesting it and killing it. But the uptake is that too, presumably. So so to get that number, you'd have to have a harvest of only like 88.4 million tons of above ground biomass. That's just nowhere near the right number. Never was. So
yeah, I think, Bob, you got to send me the numbers. I think there's too much for us now to try.
Yeah.
Okay. This. I think this seems pretty consistent with other things that we've done and I've looked at. So
Can I ask really quick? Could I ask a question, Bob? You're starting with 1 inch and above, right? I think we might have started with the bull biomass there. Assuming that if you start with the total above ground biomass 1 and above, some of that's going to be left behind and go into the down wood pool. Isn't that right, Adam?
yeah, but you don't have near enough going in there then.
No,
You're doing that.
Yeah.
You're not,
Still some-
there's way more. If you're going to do it that way, you should show the two broken apart, and then you could track that better. That's what the model would do. But
Would be different.
yeah, so that's where you went wrong. If you're gonna, because that's dead. As soon as you cut that stuff, it's all dead, right? Even the tops, right? And it's gone, right? And it may end up going downstream up here in the what you're calling what is that number? That's going back into the atmosphere, the decay. Yeah, but yeah, if you look at harvest removal, the thing it triggered, this is not the first time I've seen it. When this first got mentioned back when we first started looking at this, I was just incredulous because I knew for sure that the harvest was way more than half of the growth, whatever way you want to measure it, right? And that's what you're showing here, right? It's a little more than half, and that's just not right. The total removals, biomass, pulpwood, whatever way you want to measure it, in Maine are very close to the growth, right?
But growth is 29. Well, so yeah, well, I'm not sure. I think we have to go back, and again, you have to show me your numbers. Jeremy and I, the other thing that we did is that we did also, these numbers were lining up nicely if you start with this, right? So that's the other thing, is that we also had to convert back to what's actually Maine Forest Service is reporting as harvested, right? And that's how we also managed to
those data. Ken can comment on this, but we know those are a low estimate. I would never trust those for a state level total number of biomass. I would use it for sure to apportion the product mix, because it's probably a pretty good estimate of that, but it's not. I think it's probably not a good. It's an incomplete tally of what's actually harvested, for sure.
Could I make a suggestion, John?
Yeah, go ahead, Lloyd.
We're running low on time, and this is pretty interesting discussion. If we could ask Bob and Jeremy and Adam and maybe Ken to weigh in on this, I'd say those would be the experts on this. If they could discuss this a little bit over the next couple of weeks and maybe send us a little note what their conclusions are, then maybe we could agree that this is still subject to some discussion and see if Adam can get a little further into his presentation. But this is just what we should be doing. We should be discussing this kind of stuff.
And I think more I'm going to show you is that our numbers are lining up with other studies. So,
okay, well, show us that.
Okay. So, all right. So that's basically the key point here, is that what we've gotten to is based on those calculations that I've shown. All right. And what I'm going to skip over these other things because all this is just showing just different fluxes that are relatively small from other land use, sort of land uses and land use change effects. All right. So if you, again, take the calculations that we have, all right. So you have uptake, right? So uptake, you know, basically ignoring this sort of the conversion, removal, conversion, and decay. All right, it's 7,151 million metric tons. All right, the amount that goes into sedimentation and then wood harvest, then are ultimately sort of combusted or decayed. Basically, what you have is based on the emissions that we had before that are based on Stacy's and DEP's calculations, right? You actually have that forest and wood storage remove about 75% of what that number is, all right, on net. All right, if you account for these other sort of net changes in the other aspects of land use, you get that net land sink comes up to 78%. All right, if you account for sort of coastal water outgassing, then you get back to that total sink of about 75%. And this is what I would say is offset, but in a better terminology that's more consistent and ignores carbon markets, we can call it the word removal, right? It's removing 75% of the annual emissions from fossil fuels in the state of Maine. All right, so that's coming back to sort of John's comment. And so that's what's also suggesting here is that emissions themselves are contributing to about 25% of this total atmospheric number. All right, so these are a couple other things that I just want to point out. So Stacy has shown a couple times already these, basically this green line, which is the gross greenhouse gas emissions. I think she had one that was green and blue, and one of them was fossil fuels, and one of them was everything else, right? That everything else is mostly agriculture and maybe a bit of industrial or something like that on top, right? That line is the green line, right? So that's the one that's not adjusted for this biomass. The red line is the one that if you actually go and look at a recent publication by the Forest Service, this is what they estimate as net forest ecosystem sequestration within Maine. So this is the growth less removals. This is the sort of total number that you might see, ignoring the actual products, but acknowledging that there are removals that come into play of getting to what that net ecosystem carbon sequestration is, right? So this is basically anything below the x-axis, meaning that growth is exceeding removals on any year-by-year basis across the state of Maine. Right. And so that's been consistent, that's been doing consistently over the entire study period, but even more consistently, it's been pretty straightforward over the last 10 plus years. So if you take the number that we came up with and you actually just, you know, basically because we're doing an average over that 2006-2016 period, right, convert that to metric tons of carbon dioxide equivalent, we're getting basically right along that lines of around 11 million metric tons net sequestration in forests per year. Which is right in line with what this net estimate is for forests, what we call, again, removals. What I've also tried to do is just look at, again, how our pools are estimated in, you know, the average estimates in our pool over the latest Forest Service number. And that sort of shows that they're also lining up. Forest Service seems to have more in the dead biomass state. And then the other thing, I think that's all I have there. The other thing that we could look at, if I can get my screen to work, is that question that Bob had, where you can also look at, hopefully people can see this. This is basically the estimate over time in sort of above ground and below ground. And so this is that by far the above ground, the flux, not necessarily the storage, the amount stored below ground, but definitely the flux or the annual sequestration is dominated by this above ground biomass. But in our estimate that we show in the budget, we're basically summing up the orange and the gray. You know, given there's only 5 minutes, I guess I can stop there. If there's more questions, we can get into that. You know, I can always come back another time and do the harvested wood product talk, because there's always more about also, you know, roughly on average, it's less than 30% of anything harvested in Maine actually ends up stored in a product or the landfill, sort of on average over a 100-year period, which is another sort of amazing number that people tend to sort of scratch their head at, but it's very consistent. with other studies we've seen and the methodologies that Grant discussed a few weeks ago.
Adam,
Adam, that's not really a constant, is it? Doesn't that kind of drain off over time? Doesn't that, you have to define a year when that's true? 30%?
Yeah, so I'll show this, Bob, then.
Okay.
Yeah, so this is basically are people seeing this?
Yeah.
This is,
yeah.
right? And so the thing is that, to really do this right, we need to know what was harvested 100 years ago in Maine, right? And do this calculation for every period, year on year on year on year, right? So there's ways that you can sort of do that. What we've done is sort of taken a 100-year average over this sort of the level of different types of products and the decay in these products. So that's sort of what we've used for that number there as a result.
Adam, I'm wondering if your offer is good for coming back and doing the harvested wood products. That would be fantastic, especially if it isn't asking too much. You've got this all ready to go. I wonder if we could take just a couple more minutes to think about the policy. Adam, I think you're the policy guy too, or at least that's one of your responsibilities.
Yeah.
How do you see, if the state has this carbon neutral goal, can you speculate on what might be done to get the forests to do more, since it's privately owned, to get it to do more to get to the state's carbon neutral goal? And I know that was a really big question, but I at least wanted to cue it up, because that is the big story, right? Kind of.
Yeah. So there's two things that I see with that. So one is that I always point out is that this looks like forests are doing more than their fair share, right? In the sense that right now, basically Maine, again, based on, I think it doesn't actually matter which way we calculate it, because as Stacy pointed out, if you include all the biomass emissions, that's emitting like 11 million metric tons. But we estimated that that's how much wood we're not accounting for in this removal estimate. So maybe that's actually going to net out anyway, which is nice. So the thing I point out is that, Maine now is already down to 5 million metric tons carbon dioxide per year on net, if you assume that sort of the calculations of forests are on par, right? So the question is, how much more can forests do to get this blue line down, right? If greenhouse gases were held constant. So, there's still a lot of parts of Maine that probably aren't managed to an optimal condition, right? In terms of optimal stocking, interventions on management, silviculture, et cetera. Or, others that maybe are harvested too intensely compared to what they could, right? And so it's about sort of how do we even out that balance? Some of the other stuff that we've done is try to look at different practices to change incentives, right? So there could be, and the kind of two ways that you look at it is that you can do sort of similar to what's done with Reggie, right? Or any things we've talked about. What are some incentives basically through carbon markets, right? Or some other ways, or what could we do things like pay for practices to get people to change their silviculture, right? I guess better idea of what the land, an optimal landscape could look like, where maybe we could focus on, if we need to do more sort of set asides and things like that, where should we target that? An efficiency, there's efficiency gains plus and minus for doing this sort of straight up carbon credit approach versus paying for practices and stuff like that. The talks I've had with a lot of people are suggesting that people would happily do more silviculture if they could. And the issue there is that they just can't afford it. That's the argument. I could do more, but I don't have the cash flow to do it at the time, right? Because I'm not going to get that return on investment for another few decades if I do it, right? So how do we provide incentives to get people to invest now for what's obviously going to lead to impacts in the future?
I'd sure like to comment on that.
Yeah, I was going to come in quickly too, if I could, John.
Mark, yeah, go ahead. Bob, we'll come back to you.
Okay.
Just want to, you framed that, as how can our forests do more to meet our state's goal of being carbon neutral? And remember that we also have a state goal for 80% reduction in gross emissions. if our forests keep doing what they're doing now, and we meet our state goal for 80% reduction in gross emissions, we're going to be better than carbon neutral. So yes, we want our forests to do more, but when we think about our state's goals, we should keep both of those goals in mind and recognize that part of our effort with regard to our forests is defense of the good that they're already providing.
Mark,
so improvement is important, and I love it, but what they're already doing is pretty good.
Thank you for that point, Mark. Bob, I'm going to come back to you in a minute. Hang on,
Sure.
everybody. I just want to make sure it's 3 o'clock. If you have to go, you can go. There's no police here. Just go. But if you got 10 or 15 more minutes, maybe we'll stay and continue the conversation. But go.
Yeah.
Don't feel bad about getting off if you got to go. So thanks for being here if you do. Mark, thank you for that point. And by the way, when Jake and I think Ken were playing around with numbers earlier on, we had figured out if we just keep doing what we're doing with the forest, we'll hit carbon neutral in 2037, way before 2045. So good point there.
And the hard part is that there are no guarantees that we continue to get the result that we're getting.
Right.
Most of it is uncertain.
Right.
Yeah.
Yeah, and that's a good reminder, Mark, because that's what I was trying to get at when I first started that comment, is that it looks like Maine's forests are doing great right now, but if you do at least some projections, depending on what you assume about different parts of the state or whatever, you could see certain starts becoming net sources as opposed to sinks, right? And I think Jeremy's also been investigating that as well. So just because we're sort of consistent here over the last sort of 10 years does not mean that that's going to hold, right? I mean, a lot of this, we can come up with different reasons of why it is what it is, but it's a legacy of what happened sort of in the 80s and where the forests, sort of the state of the forests are today as a result, I think.
Now back to Bob. Can I frame up a question for you, Bob? And maybe you can answer it, or it's where you're going anyway. Silviculture. You and I have been around long enough that we know what it was like 30, 40 years ago.
Yeah.
Can you comment about how silviculture has changed in the time you've been watching it? And does that plug in here?
To some degree, I'll just, as background, I'm writing a series of articles for the Maine Woodlands newsletter. The one I just turned in, which will come out in a couple of weeks, Jen Hicks, the editor, wanted me to talk about the biology of carbon fixation and then use that to as the basis for looking at what kinds of silvicultural systems are good or not good, right? And so I plotted some of my research data that we looked at early on in these things versus the actual. I went out to the Evalidator. That's why I'm all over this now and conversant with the numbers. And looked at the average stocking versus the potential stocking that we know from research data. And, one way to think about this, and I say this right in the article, if we wanted to maximize carbon sequestration in the state of Maine, we would stop cutting trees, right? That's just that simple. And that's a non-starter for most people, right? So it's not about A or B, either putting everything in a reserve or keep making silviculture more aggressive. The kinds of silviculture that you're talking about, Adam, where it talks money, is not the kind of silviculture we need. The kind of silviculture we need is like the Bureau of Parks and Lands uses, many small woodland owners use, much longer rotations, higher stocking levels, where you both get, so if you manage up around 30 to 35, 40 cords per acre, you will sequester just as much, if not more carbon than Irving will in their spruce plantations. And that's especially true when the fact that those short rotation stands may be growing and sequestering a lot of carbon temporarily, but as soon as they're harvested, it's almost all gone, right? So it hasn't done any good at all. Whereas keeping that stocking in a multi-age silvicultural framework, you both get high carbon rates of sequester growth, as well as high board foot volume growth rates, where you actually make money selling those trees. Plus, guess what? The products are much longer lived and last longer. in the product stream. There's just no downside to it. So it's very clear to me that there's only one strategy that's going to work, and we have to back off a little bit on harvest to allow lands to become more heavily stocked and managed, with natural regeneration at higher stocking levels. And then you will get both higher carbon and higher value already, right? That's the alternatives. I was thinking about this. Lloyd gives this presentation where he shows in Dave with this spruce plantation, right? It grows all this damn carbon. And then you can start thinking about, we learned in forestry school that we're going to optimize a rotation using this mean annual increment. So I said, oh, we'll do that for carbon, right? MAI, PIF carbon. I pulled it right off the validator, plotted it up. And then I realized that is not like board feet or cords. Because when we maximize a timber rotation on base of dollars, basically, as soon as we take our dollars, nobody gives a shit what happens next. The money's gone, the trees are gone, and we plant a new stand and off we go again. With carbon, the good has not yet been done until that carbon is permanently out of the atmosphere. Otherwise, you haven't done a damn thing, right? So so you can optimize the rotation with a short rotation spruce plantation, and it looks great as long as you're only counting what you grew, not what you actually stored, right? And those two are very different numbers. If you do this with FVS, this is why we need to, Adam, I got to talk to you about the modeling aspect of this. And look at long-term scenarios, you only get about 15 to 20% of the carbon that you grew, even under this kind of silviculture, actually really ever stays around if you cut all the wood, right? 80% sort of goes back into the atmosphere over many decades, right? Some immediately, some over a long period of time. 30 seems high to me, but that may just be that model's wrong, and you're right. I'm not an expert, so. Yes, so management needs to change in favor of higher stocking. You can definitely do this by looking at northern Maine versus southern Maine, where you have very different average stocking levels, or large private lands versus Maine's public lands. You'll see clear differences, right? So the data are already there. I do think also we need to sit down and look at these and look at current growth yield balances in the validator, because they're nothing like you're promoting in this carbon balance, and unfortunately they're not nearly as rosy as what you've shown, unless I've made some gross error.
Well,
there's no reason you can't pull all these statistics off of last year, right?
I'm already late for another meeting, and I want to have this continue. So how about, Bob, you come to the next meeting and you give us your numbers, right? And then we can discuss more. That might be a nice way to build off this, right?
Well, I can recalculate what I think those are for sure. That won't take long. I've already done it. Yes, we can. And then it might be more fruitful to do what Lloyd suggested, to have us, or maybe just have another separate Zoom call where we actually just walk through it like we'd have a meeting, right?
Yeah.
The three of us, me,
Adam.
You, Jeremy, I guess. Who else? That'd be enough.
If
Ken, maybe if Ken's willing to participate. Yeah, thus four. Let's just set that up, and then we can talk about that resolve. So there's two things here. There's the silviculture, and then there's the actual situation. Those are two very different metrics, but.
Adam, thank you. If you got to go. Don't worry. Appreciate it.
Sorry for holding you up, Adam.
Let's do this.
Till next time, I'm happy to work with you, Bob, or whatever. Everyone knows I'm happy to be proven wrong. So
yeah.
Any insight is useful, but hopefully that was good. John, I'll send you the slides so you can post up and people can look at this in more detail.
Okay, thank you.
Yeah,
and I got
this
the
is
recording.
excellent work.
I just want to add, realize this was a one-shot deal, back of the envelope. We took a period of time when we did a difference, we divided by 10. No one in their right mind would say, this is the way we want to do it. These balances change over time. This was a first cut effort. So this discussion is really important, but there's been no overall investment to say, let's do a statewide carbon budget, which is what we jumped to say, gosh, they're coming up with these policies. What might that look like? And of course, it was the only number in town, so that's why everyone's looking at it. But nevertheless, Bob, your points are well made, and this is the kind of analysis that we need to do. The state needs to have a process to be able to do this in an ongoing basis at this level, this comprehensive level. We pulled numbers out of the air as far as DOC and degassing from water, So there's a lot of warts, and these are really important discussions, but this was a one snapshot in time done by mathematical divide by 10. This is what we got. So all great. I felt like I needed to say that on behalf of Adam's presentation, and we were following the recipe of the soccer report for the North American carbon model from the standpoint of how we did those calculations.
Yeah, I think the methodology's there, right? That's nothing wrong with that. It's just I'm just questioning the. I
Yep,
think it.
And that's
yeah.
great. We need the
Yeah.
experts to chime in on this so we get it right.
Yeah, if you look at the total sequestration in all trees and then subtract out only the merchantable bowl part of the carbon, then that's you're missing a big chunk there. That's you're claiming is still around and isn't, I think, is my argument. But
Yeah.
I'll write this up. That's what I'll do. I'll make a one pager, send it around to people.
I see your point, Bob. Thank you for that.
I got to scoot. Thanks.
So
I had a suggestion.
So I'd like to weigh in for just a second, if I could.
Okay, just a
Can I do
second.
that? Yeah. So I agree with Bob. Basically, a tree is 50% product you can sell and 50% tops and limbs and everything else from a biomass standpoint, just roughly. So if you just count the products, you're missing the other half that gets cut down at the same time.
Mhm.
The other point is that to do the silviculture with Bob, that I agree, it requires multiple entries over time, multiple partial harvest entries over time. You can't just let her grow forever. I mean, I'm dealing with stands down here. They're 100-plus-year-old spruce stands. And if you go in, never been touched. And if you go in there and start fiddling around with a partial harvest, it's going to fall down. So that's a result of just doing nothing, which is not the answer to this.
Yeah.
Yeah. I was shorter than I was expecting, Si. Thank you.
Now is usually the time when we start talking about what would be done next. I don't know if our little gang of 4 we just designated can get this all straight by next time or not. But I noticed there's some things that I've been interested in talking about if people would want to hear it. You know, the president just announced that the price of carbon from the federal government standpoint has gone up from $7 a ton to $51.
Wow.
$51?
Administration's policy.
The social
That's what it
cost,
says.
so-called
Now,
social
the question
cost of
is,
carbon.
What does that mean? What is
That's
he
not a
talking
market
about?
price,
He is
though.
talking
No.
about a social cost of
No,
carbon.
but it's the
for
start of a
purposes
market.
policy
It's the
decisions.
start of a discussion on market price.
It is, because it's
Okay.
a new price
In the
point.
European marketplace, carbon prices have been going up. That's another thing that sort of brings this stuff up to one level of being interesting. After being stuck for a long time in the, say, 50 to 20 range, it's broken out of that. I don't know what that means or how long it's going to last, but I have some material that could be used whenever you're ready to just talk about how are those prices actually formed, what causes those prices in the carbon market to be what they are, what we read about in the paper, and then also what does this social cost of carbon mean, who decides what it is and on what basis, and we could spend a few minutes on that without necessarily taking up a whole hour and a half. If there's a way to work that in over the next couple of months, it might be interesting.
Just hanging a price on carbon is now starting the public really talking about this. And, you know, the free market, or the market is going to just be fascinating to watch. And if you give private landowners a price on carbon, basically it's letting trees grow, things are going to change a lot. Even for large industrial owners, there was somebody that I talked to last year that basically said, you know, they'd sell everything they had and buy Weyerhaeuser stock because they're going to get paid to grow trees, period. Never mind cut them, just grow them. It's going to be very interesting.
51 would move the needle completely. Yeah.
Yeah.
That's
Yes.
Robbins will be out of business. So will
No,
everybody
no,
else.
They won't be
Because
out.
I wouldn't cut a tree.
They won't be out if they'll change business. That's the fascinating thing. If the business will change and it will suddenly become a much different group of products. It will include solid wood products, but it will
Well, it
also
should. I would
include-
hope so.
Yeah, but it will also include standing carbon as a product.
Well, and I just wonder what it will do to the price of wood products, because if there's this carbon competition for wood products, the price of my 2x4 is going to go up, I think.
You bet, and it ought to.
Well,
It ought to.
it should, which I guess would constrain the consumption of wood. So I don't know whether that's good or bad, but that's probably as for an economist and not me.
Well, if we price the substitutes even higher, their carbon costs, then the market should take care of that, right? We'd build everything out of wood, even
If
though
we did.
that would be more expensive. It would
If
be
we
less.
did.
Exactly, exactly.
Yeah.
And that's probably where it's all going. It's just
Yeah.
probably not
Right.
next year, but
Yeah.
sometime
I
in
mean,
the next
it's-
decade or two.
Well, 2x4s are already $5.50, $6. They used to be $2.50, right? I
Well,
mean,
some-
that's like
somebody
somebody's
said
making a windfall.
$9.
And the stumpage sellers,
Right.
for God's
Right.
sake. I didn't.
Not going
I
Also,
bet
to
Si's
last
not
year-
getting twice as much for his spruce logs as he was a year ago. I know I'm not.
It's just like any waste stream. We took it for granted. You threw it in the river and disappeared. It was free. Now you throw it in the air and it disappears. It's free. All those free things are going away.
Mhm. Yep.
Love it.
Okay, Lloyd and I will get together and come up with a plan for the next meeting. Lloyd, you're nodding, so that's good. And it sounds like we've still got things to talk about. So I guess we'll keep going if everybody wants to. Whenever it's just Lloyd and me, we'll probably stop. But we haven't hit that point yet.
Yeah.
So,
Well, thank you for doing this.
well, I mean, just revealing some of the questions today was really good. I think the group has a purpose. So,
I mean, I didn't actually know that we weren't counting wood emissions. I mean, that just floored me when I
well,
realized that.
I've known that, but not
Yeah.
for long.
And that's and that they're a major. They're non-trivial.
It's
as I say.
non-trivial. Exactly. That's kind of big
Yeah.
news. So,
Okay.
all right. We'll stay in touch with everybody.
Great,
Thank
John.
you. Thank you all.
Good seeing you all, people.
Okay. Bye.